In this video, we're going to look at some waves multiple choice questions. Before each question, I will pause for a second or two so you can try the question before I go through the answer. So pause the video now and try these questions. So longitudinal waves, sound is almost always the longitudinal wave that is given as the example. All electromagnetic waves are transverse, so we can all represent them like this. Water waves on the pond, again, we can represent them like this. Sound waves are longitudinal, and we can represent them like this, with regions of compression and regions of rarefaction. And the particles are oscillating this way, which is parallel to the direction of motion of the whole wave. Question 2. In exactly 2 minutes, 6 complete wavelengths pass the buoy. What is the frequency of the waves? So frequency is the number of waves per second in 1 second. So in 2 minutes, we have 6 waves. So that's 2 times 60 seconds, which is 120 seconds, and we have 6 waves. So in 1 second, we must have how many? We have 120 over 6, which is 20 waves. So 20 waves per second is this. Okay, pause the video now. Try these questions. So we should know that humans can hear between 20 and 20,000 hertz. If we go this way, it becomes ultrasound. And if we were to go the other way, it is infrasound. So the highest frequency is obviously D. Question 4, which sound is louder? Which has the lower pitch? So the loudest sound, the loudness relates to the amplitude. This is the amplitude, so it's got to be either A or B. And the lower pitch, well, pitch relates to frequency. So this has a lower frequency compared to this. So this has a higher pitch compared to this. So lower pitch is also going to be P. So the answer is A. Which row shows whether or not the speed of the water waves change? So reflection, the answer is no. All right, because the waves, they come in, they bounce off at the same angle that they came in at. The angle of incidence is equal to the angle of reflection, nothing to do with the speed. Refraction is all to do with the speed of the waves, because waves come in, they change density, or optical density, they change speed, they change direction. So this one, and diffraction, even if you don't know what diffraction is, it has to be B. There's no other one it can be. But diffraction is when the waves come in, they go through a gap and they spread out. Nothing to do with the speed at all. Okay, in 2 seconds, 3 wave crests are produced on the surface of the water. These are the wave crests. Which statement is correct? So distance x is the amplitude of the wave. Well, that's obviously incorrect, because we know that the amplitude is the distance from the equilibrium line to the peak or the crest. So that is obviously wrong. Distance y is the wavelength. Let's have a think about this. So this is a crest, so that would be this point. This is a crest here, and this is, sorry, I'm not incorrect. This is a trough. So this one here is here. So y would be the next point here. So that is not a wavelength. That is 2 wavelengths. Each circle represents a wave front. That sounds a bit more realistic, because that is what we are representing here. When we draw diagrams like this, we are talking about the wave fronts. And what's this? The frequency of the waves is 3 hertz. So in 2 seconds, we have 3 wave crests. So in 1 second, we have 1.5. So obviously, that is incorrect. Why does dispersion occur? So we have white light, it goes from air into glass, it's going to change optical density, it's going to change speed, it's going to change direction. This is an example of refraction. So refraction is this fact here that changes direction, and also this fact here, the fact that it spreads out like this, that is dispersion. So which of these statements is correct? Well, it's to do with the speed, not the frequency. So it's got to be C or D. And which one of these is slowing down the most? Well, you can see that violet is bent the most. So we can say that the speed of violet light decreases the most. Okay, 3 questions. Pause the video now. So echoes are when you have a sound wave that is traveling out and it hits a surface and then it rebounds in the opposite direction. So that is clearly an example of reflection. Light waves and radio waves are both part of the EM spectrum, the electromagnetic spectrum. So they are very, very similar in a lot of ways. So they are both transverse waves. The difference is that if we sort of sketch a quick EM spectrum, here we have a much higher energy, much higher frequency, much shorter wavelengths, and light is further towards this end than radio. So the differences are light has a higher energy, a higher frequency, and a lower wavelength. The unit of wavelength, or the clue, is length, so it's going to be meter. Pause the video for this question. So how many wavelengths are there between X and Y? Well, this here is one wavelength. So here we've got an extra half of a wavelength. So it must be 1.5. What is the name of this curving effect? So that is the first part of the question. So it's diffraction. So C and D are wrong. That's when waves spread out when they pass through a gap. How can the gap be changed so the waves are less likely to reach the boat? So we want a smaller amount of diffraction. So maximum diffraction happens when this gap size is similar to the wavelength of the waves. So we need to make the gap slightly bigger, and then it will be even further away. So A is the answer. Which sound has the highest frequency? Frequency is the number of waves per second. So the scales are the same, which is really important. So which has the most waves per second should be pretty easy to see that it is D, because it has the shortest wavelength and the highest frequency. Which statements are correct? So we've got a number of combinations here. So the easiest way to do it is to go through each statement in turn and think about whether it's true. So infrared waves are used in television remote controllers. That is correct. Radio waves are used to transmit television pictures from satellites to Earth. It's microwaves. Ultraviolet waves are used for intruder alarms. No. X-rays are used for security checks. Yes, they are. So it's 1 and 4. So it's B. How could a ray of light pass through a glass block in air? So this is glass, and outside, importantly, is air. So if we go from air to glass, what is happening? We are going into a higher density. So the speed will decrease and it will bend towards the normal. That's always very crucial. So the normal is the line that is at 90 degrees to the surface where the light ray touches. So we could draw on the normal here. We could draw on the normal in these ones here. And what do we see? Well, C and D, the light is approaching at 90 degrees at the normal. So in that case, it will just travel straight through. In B, it bends away from the normal. So the light would be going this way, it bends away from the normal, whereas in A, it's going this way, and then it bends towards normal, so it must be A. Final questions, pause the video now and try them. Which statement describes the waves? So it's all about loudness and pitch. So the loudness is related to the amplitude, and you can see that they have the same amplitude, so they have the same loudness, so it must be C or D. What about the pitch? Well, we know the pitch is related to the frequency. This wave here has a higher frequency, it has a shorter wavelength, so wave 2 will have a higher pitch, so in this case it must be a different pitch. Student claps once while standing 100 meters away from a large wall. Always worth sketching a quick diagram if the situation is getting a little bit more complicated. The speed of sound in air is 330 meters per second. How long in time does the student hear an echo? So we're being asked to do speed is distance over time, but we want time. So we need to make time the subject of the formula. So speed times time equals distance, because we're timesing both sides by time. And then we need to divide both sides by speed. So time is distance over speed. And what do we need to put in? So time, the speed is 330. The distance is not 100. That's a very common mistake because the waves have to go here and they have to go back. So the distance is 200 or 100 times 2. So now we've got 200 over 330. Which is 0.61 seconds.